Let us suppose that we have a function f of x, and this is defined on some interval x1, x2. Let's look at it graphically. We'll consider a very random function. So this is function f of x. So we are supposing that it's defined on some interval x1 and x2. Now, suppose this particular function, even though it looks very smooth, let's say it is not defined at this particular point, which is x equals to a. Then we say that the limit of this value of the function f of x when x approaches a. So x approaching a means we can either come from the left hand side or we can come from the right hand side. So when we approach the value of fx, we're saying that it has a limiting value of L. And that simply means that the difference f of x minus L, we're saying that this tends to 0 as x goes closer and closer to the value a. So here fx, when calculated at x equals to a, we are saying that this is not necessarily equals to the value L. Or we are saying that what happens to the value of the function f of x as it approaches a. So let's try to understand this particular problem with the help of an example. Suppose we have a function given by f of x is equals to sine x over x. So we'll try to graph this particular function. So this is not exactly sine x, but this is going to have an oscillatory nature. So the function looks, if we use our graphing calculator, Desmos, so this is going to have a shape of this particular sort. Now the question is, what is the limiting value of this particular function sine x over x when we approach x? That means when x is approaching the value 0, that means at the origin. What is the value of this particular function? Here, if we again use Desmos, it will show that the value of the function at x equals to 0 is 1. But that is not actually true, because at x equals to 0, f of 0, that will be equals to sine 0 divided by 0. We know the sine of 0, it has a value of 0, so we are getting an indeterminate form. Indeterminate form means we cannot define the value of this function at the origin. So whenever we are unable to define the value of this function at the origin, so we have to represent it with the whole here. So whole suggests that we cannot define the value of this function at x equals to 0. But what we're trying to do is, what is the value of sine x over x as x approaches 0? That means when we are in the neighborhood of x equals to 0, what is the value of this particular function? Although we are not concerned when we talk about limits, we are not exactly concerned about what is the value of the function at x equals to 0. All that we care about, what is the value when x approaches 0. That means we can come either from the left hand side or we can come from the right hand side. In the neighborhood of x equals to 0, we'll say that this value is equals to 1. Now, we can also check the value of this function as x approaches 0 numerically. So, numerical means we are going to consider some numerical values. So, let's say we take x equals to 0.01. So this is not exactly 0, but this is in the neighborhood of 0. So in that case, our f of x, which is 0.01, so that will be equals to sine 0.01 divided by 0.01. So this is the value of x and this is sine of x. So when we use a calculator, we obtain the value 0.99998 and 3 is going to repeat. So I'm using the bar here. So bar up atop 3 means the 3 is repeating. Then we take another value. Let's say x equals to negative 0.01. 0, 1. So that means we are looking at x from the left hand side, or we are approaching x equals to 0 from the left hand side. So this will be negative 0.01, which will be equals to sine negative of 0.01 divided by negative 0.01, and this also gives us exactly the same value, 0.99998 bar. So we can make a guess here that when we take the limiting value x approaching 0 for the function sine x over x, so this is going to approach the value 1. This is not exactly equals to 1. We are saying this is approaching the value 1 when x approaches 0. So 1 is the value of this particular function sine x over x in the neighborhood of x equals to 0. However, this is not a proof. It only gives us a very strong support for our answer. So let's try to investigate more limit problems. So let us consider another function. So we will try to find out the limiting value of this particular function about the origin, and the function is given by the absolute value of x divided by x. Again, we can use this MOS to obtain a graph of this particular function. However, this is a fairly simple function. So we will have to consider two values of x for x greater than 0. That means when x is positive, then our absolute value of x divided by x. So this simply becomes positive x over x. So this is equals to positive 1. So this is going to have a value 1 for x greater than 0. Then for x less than 0, then the absolute value of x, this simply becomes negative x. So we have negative x divided by x. So this gives us negative 1. And our function is going to have a value of negative 1 for x lesser than 0. Now, the question is, what is the value of this function at x equals to 0? So if we try to find out the value of the function at x equals to 0, so we will have absolute value of 0 over 0. The absolute value of 0 is simply 0. So we again have an indeterminate form. This simply means that our function does not have any value. It simply blows up at the origin. So it cannot have any value. So that is why I'm representing it with a hole. This hole represents that we cannot exactly say for sure what is the value of this particular function, because there is an arbitrariness from the diagram here. We can say, is it 1 or is it negative 1? So we cannot say for sure. That is why I'm using a bubble here. Now let's try to find out the limiting value when x approaches 0. So there are two ways of looking at it. So we say that this function, absolute value of x over x, we want to find out the value of this particular function. So when x approaches 0, but we want to come from the right hand side. So that means since we're coming from the right hand side, we are putting 0 raised to the power of positive. Actually, it's not raised to the power of positive. This is just a notation which is telling us that we are calculating the limiting value of this particular function as we approach this value x equals to 0 from the right hand side. Now this will be equals to, so we have limit x approaching 0. Now we're going to drop the sign here. That is because since we are coming from the right hand side, so in that domain, we know that absolute value of x is simply x over x, which is 1. So the limiting value of x approaching 0 for 1, that's equals to 1. Now we will calculate the limiting value of a given function, absolute value of x over x, when x approaches 0. Now we will come from the left hand side. So 0 with minus sign, this indicates we are coming from the left hand side. So this will be simply equals to limit x approaching 0. So since we're coming from the left hand side, the absolute value of x will be negative x over x. So this is equals to negative 1. Now clearly we see that these two limiting values are not equal. When we come from the right hand side, it has a value of positive 1. And when we come from the left hand side, it has a value of negative 1. So that means this particular limit is undefined at the origin. Let's move on to the next problem. Problem number 3. So here we have the function given by x squared minus 4 divided by x minus 2. And we want to find the limiting value of this particular function when x approaches 2. Now, first, let's try to do it graphically. So we are going to use Desmos. So desmos.com. So this is a online graphing calculator. So here we can plug in this expression, and this is going to give us a graph of this particular function. So let's do that. So this is the graph of this function x squared minus 4 over x minus 2. So according to this graph, so at f calculated at x equals to 2, the value is, so this is 2. So this corresponds to the value 4. However, this is not correct. That is because if we actually substitute the value of x with 2 in our given function, so we should get 2 squared minus 4 divided by 2 minus 2. So this is equals to 4 minus 4. So that will be 0 over 0. So this is an indeterminate form. So that means in actuality, so the function simply does not exist at x equals to 2. So what we want to do, we want to find out the limiting value of this particular function in the neighborhood of x equals to 2. While we cannot find out the value of this function at x equals to 2, but we can try to find out in the neighborhood. According to this graph, it seems like we have this graph as approaching the value 4 as it reaches to from the left hand side, and when we come from the right hand side, it is also approaching the value 4. So this is what our figure is suggesting. So let's try to do it numerically. So for that, we are going to assume certain values. So let's say we are going to consider in the vicinity of 2. So let's say we consider the value 1.999. So this is slightly lesser than x equals to 2. So that means we are trying to approach x equals to 2 from the left hand side. So for this particular value, our function, which is f of 1.999, this will be 1.999 squared minus 4 divided by 1.999 minus 2. So let's use a calculator to find out the value. So we get 3.999. Then let's take x equals to 2.001. So that means we are approaching x equals to 2 from the right hand side. Then the value of the function will be, we have 2.001 squared minus 4 divided by 2.001 minus 2. So this should give us 4.001. So from these two values, so that means where we have calculated in the vicinity of x equals to 2, we can make an assumption that the value of this function f of x in the limiting value when x approaches 2 is equals to 4. However, these results are not enough to make any conclusion about the value of this limit. This is just an estimation. This is what we are saying, that this is approximately equals to 4. However, what we can do, we can use some algebraic technique. So let's now talk about the algebra. So this can be also expressed as, so we have x squared minus 4, which is actually x squared minus 2 squared. Now we can use the identity a squared minus b squared. So that's equals to the product a minus b times a plus b. So that means we have x minus 2 times x plus 2 divided by x minus 2. Now we can factor out x minus 2, which is common to both the numerator and the denominator, and that leaves us with x approaching 2, x plus 2. So this, we simply now substitute the value of x with 2. So this is giving us the value 4. So this means the limiting value of this particular function when x approaches 2, that's 4. So we're saying that this is also approaching the value 4. So never think of it like that the value of this function is 4. It's just that in the neighborhood of x equals to 2, the value of the function approaches the value 4. Let's move on to the next problem. Example number 4. So let's try to investigate the limit. So we have limit x approaching 2. So we consider the function x squared minus 5x plus 6 divided by x minus 2. Fine. Now let's say at x equals to 2, f of 2 will be equals to, so we have 2 squared minus 5 times 2 plus 6 divided by 2 minus 2. So we have 4 minus 10 plus 6 divided by 0. So 4 minus 10 plus 6, so that gives us 0 divided by 0. So again, this is undefined because this cannot be determined. So we can say that our given function f of x does not exist at x equals to 2. Although the function does not exist at x equals to 2, but what you're trying to do here, what is the limiting value of this function when x approaches 2? Or what we're trying to find out is, what is the value of this particular function in the neighborhood of x equals to 2? So this means that, let's do some algebra here. So we have f of x given by x squared minus 5x plus 6 divided by x minus 2. So if we factorize this numerator, so we get x minus 3 times x minus 2 divided by x minus 2. So x minus 2 gets cancelled out. So this is equals to x minus 3. Now this is a linear function. The linear function means if we plot the graph of this function, this is going to be a straight line. So this is going to look something like this. So this has a intercept of -3 and a positive slope. So this is our x-axis, this is our y-axis. So this is the graph of x minus 3. And at x equals to 2, so this is the point where we have x equals to 2. So this is where the function does not exist. So instead we have to represent it with a hole. So this is how we can represent the graph of this particular linear function. So simply the function does not exist at x equals to 2. Now we will do a numerical investigation here, because we are trying to find out the value of this function and the neighborhood of x equals to 2. So let's take some values. So let's take x equals to 1.99 and we're going to take x equals to 2.01. So this is in the neighborhood of 2. So here 1.99 means we are approaching 2 from the left hand side, and 2.01 means we are approaching x from the right hand side. So let's do it. So the value of the function at x equals to 1.99, so this will be, so we had x squared, so 1.99 squared minus 5x, so this is 5 times 1.99 plus 6 divided by 1.9 minus 2. So we'll use a calculator and this will give us a value -1.01. And let's find out the value of the same function but calculated at x equals to 2.01. And this is giving us a value 0.99. So here we can say that numerically we can say that the value of the function at x equals to 2, this is going to be approaching the value -1. Then again, this is not a proof, this is just a way of checking what will be the value of this function at x equals to 2. I mean in the neighborhood of x equals to 2. Let's do one final problem. Problem number 5. So we need to find out the limiting value of this function sine 3x over sine 2x when x approaches 0. So we have the function f of x given by sine 3x over sine 2x. Now at x equals to 0, the function is going to have a value sine 0 over sine 0. And we know the sine 0 is simply 0. So we are getting a 0 over 0, which is a indeterminate form. That means we cannot say for sure what's the value of this particular function at x equals to 0. But here we are asked the question, what's the limiting value of this function at x approaches 0? Meaning in the neighborhood of x equals to 0, we need to figure out the value of this particular function. Now, let's head over to desmos.com. So this is the graph of sine 3x over sine 2x. So at x equals to 0, we know that the graph does not exist. It's an indeterminate form of 0 over 0. However, looking at this graph, we can say that this particular point corresponds to y equals to 1.5. So we can say that the value of this function is going to be somewhere between, somewhere in the neighborhood of 1.5. So let's try to check numerically as well. So we will consider few values in the vicinity of x equals to 0. So let's consider the value x equals to negative 0.01 and x equals to positive 0.01. So we have sine 3x, so 3 times negative 0.01 divided by sine 2 times negative 0.01. So this will be negative sine 0.03 divided by negative sine 0.02. So let's plug this value into a calculator, and this should give us 1.49987. Now let's take the case of x equals to 0.01. So this will be simply sine 3 times 0.01. So that's 0.03 divided by sine 2 times 0.02. So that will be 0.02. And this is also going to give us the same value, 1.49987. So we can say that the limiting value of the function sine 3x over sine 2x. So this is going to give us a value of 1.5.